Welcome to chemistry. This is Miss Armstrong. I'm going to try to do a naming review for the first time with my new wireless pad. So this whole unit has been on naming. We learned how to name ionic compounds, and we learned how to name molecular compounds. So two main categories. And the ionic category consists of usually a metal and a non-metal. The metal is usually a positive thing, and the non-metal is usually a negative thing. And it's ionic because you're combining a positive thing and a negative thing. In there you could have the regular ionics. So perhaps a regular ionic might be a metal, like sodium, and a non-metal like chlorine. And we know they hook up that way. So if you look at the charges, sodium's a 1+, chlorine's a 1-, and you need just one of each of those. We also have, we'll do it from the naming. If I gave you the name potassium, what should we have? Potassium iodide. Iodide. We would look up potassium and write the letter K, and we look at the charge, it's a 1+. We find iodine or iodide, it's an I, and it's a 1-. We only need one of each, so we rewrite it with no charges, K and an I, big K and a big I. Those are regular ionics. If we want to make it a little more difficult, we could do variable ionics. And variable ionics are metals that are usually transition metals. It's not all transition metals, it's just some of them that have more than one charge. For example, if you look at the periodic table, you'll find that iron could be a 2+ or a 3+. And if you look at the one next to iron, cobalt, you could be also a 2+ or a 3+. And when you write these out as the full name, you have to specify which one you have. For example, if you had FeO, you would have to tell me what iron it is. And you can start at least by saying, you have oxygen, which is oxide. And you do have iron, but you have to say which iron it is. And you have to use parentheses. And you figure that out, you go to the oxygen, and oxygen's always a 2-. You have one of those and one Fe to make that cancel or balance out. It must be a 2+, and 2 is represented by a Roman numeral 2. So those are the variables. And you're going to have to erase some of this. And now we're going to look at the ionic polyatomic. So we did ionic regular, we did ionic variables, and now we're going to do the polyatomics. Polyatomic means it's coming from your pink sheet. And so a polyatomic might be SO4 2-. That one's in the second column, or perhaps it's in the third column, PO4 3-. They come as a set name. You can't change that name. And if it helps you, maybe you want to write them in parentheses. You cannot change how many S's or O's there are, or in this one, how many P's or O's. The only thing you can change is the number on the outside. And that number, you would change it such that you can get the charges to cancel. For example, let's say we did sodium sulfate. Right? From above, we have that sulfate's a 2-. If we look at sodium, it's a 1+. We would need 2 sodiums for 1 sulfate to make it cancel. And that's how you would write that. Now let's do something with phosphate. Let's say we had, let's crank it up a notch. Let's say we had vanadium 4 with phosphate and put them together. Now one's a 3-. You would need 3 vanadiums, and I did the cheater way, it doesn't work all the time. I took that 3 and I know it's going to go down there. So I'm rewriting it without the charges. And I know I'm going to need 4 phosphates. So you go PO4. And you got to put parentheses around here because you have more than one of them. And you can't touch what's on the inside, but you can definitely change the numbers on the outside. That's a 4. It's looking uglier and uglier every minute. So that's vanadium Let's name it vanadium. And we had that 4 up there, Roman numeral 4, because vanadium is a transition metal with more than one charge. Vanadium 4 phosphate. And if you see the 8, it means it probably came from your pink sheet or your radical sheet, because it means it has oxygen in it. So we've done the ionic regulars, we did ionic variables, we did some ionic polyatomics with regulars and variables, and then after that we did naming acids. I think we need a color change for the acids, since acids are usually represented by red. So now we're going to do some acids. All acids start with the letter H. There's an acid. Let's see, H2SO4. Let's make one up. Let's say we have nitric acid. So if I gave you the formula, I'd want you to give me the name. You don't name the hydrogen. You look at the last part, and that came from the periodic table, and its name is chloride. So ide, according to your little cheat sheet, becomes, strange but true, hydro, and then we're going to fill in the blank. We'll change the suffix indine to ic, and we're going to call it acid. So we take the base of that name, which is chlor, and that's going to become hydrochloric acid. And so notice, anytime you have hydro, there are no oxygens in the formula. This next one, what we do is we look at SO4. There's more than one element. It must be on the pink sheet. If you look hard enough, you're going to find sulfate. So we're going to change that 8 ending, because 8 changes simply to ic. And sulfur changes its spelling just a little bit. It becomes sulfuric acid. And this last one says nitric acid. So nitric, we have to work backwards here. This ic came from an 8. So it means it was nitrate. And nitrate means it's on the pink sheet. And nitrate is NO3 with a 1 minus. Now that we have to make it an acid, we have to have an H. The slick trick is to look at the 1 minus. It means you need 1 H. So you go H, NO3. Voila. Again, acids are ionic compounds because they're a combo of a positive thing and a negative ion. Let's move on to the last one, moleculars. And moleculars are 2 nonmetals, a nonmetal plus a nonmetal. And since the charges don't add up, don't look at the charges. What you are going to want to look at, though, or ponder, are prefixes. Since you can't use charges to figure out how many you have of each thing, you're going to use prefixes. So, for example, if I give you SO2, there's no way you can get the charges to add up to 0. You're going to call it sulfur. The first one's always the first full name. And then oxygen is changed to oxide. But you have to tell me how many oxygens there are and use the prefix di. What if I gave you selenium? This is the easiest way. Selenium monochloride. Anytime you see the prefixes, it's a hint that it's a molecular compound. You find selenium, you just write Se, don't look at the charges. Mono means 1, and chloride is chlorine, so SeCl1. And you don't have to write the 1. You never put mono on the front part of this because it sounds silly. But if you have more than one, for example, if you had C2H6, I'm just making this up, I don't know if that's possible. 1, 2, 1, 2, yes it is. I know the proper organic chemistry name is meth, F is ethane. But on this test, if you wanted to call it dicarbon hexahydride, that sounds really awful, doesn't it? Hexahydride, you could. But the most appropriate name is really and truly ethane. That was not the best example. So let's recap one more time. We named ionics, and we named moleculars. And ionics are usually a metal and a nonmetal, or they could be a metal and a polyatomic. They could be a polyatomic and a nonmetal. They could be a poly-poly. poly plus a poly. And they could also be acids. I hope I didn't forget anything. And in there you could have variables. The metals are the variable part. The polyatomics are not the variable parts. In the molecular, you had a non-metal and a non-metal, and you only have two elements. For example, like ClO4. I will not give you one that says H and like an Se and an F. That doesn't look good. So I wish you luck on studying for your test.